So Friday, guys, we looked at solving equations in three variable form, systems of equations in three variable form, which meant three equations, three unknowns. We looked at the example 1, and we got an answer. Example 2 was no solution. So honestly, guys, we need to finish up one more page here. So if you guys will run off to the third page here. Example 3, I want to finish this up. I'll have a short, quick quiz. I did send out a new online assignment this morning, so you'll want to look at that, see where we're at with this. I really shortened it up. I think your online assignment is only like 6 problems, knowing that these are very long. Now, when you go into your online assignment, are you going to be able to do this assignment without having a sheet of paper beside you? Probably not. So you want to make sure you have that out as you go through them today. Okay, so we'll finish this up. We'll get a quick quiz going. One thing I'll advise you of tomorrow, we're going to have kind of a work day / review day. Thursday, we've got kind of a big quiz coming over the first 4 sections of chapter 2, first 4 sections of chapter 2. I can tell you Friday we'll start new notes, and I know that this is a homecoming week, so don't plan on too much homework outside the classroom today. Said quiz will be Thursday. Friday we'll start new notes, and there probably won't be any homework Friday over this weekend, so just kind of focus while you're in class, and then enjoy your time outside of class. Sound like a fair deal to you guys?
Yeah.
Okay. All right, guys, let's talk right here. Take a look at this system of equations right up here. Now, first thing I told you up here, solving a 3-variable system. This one here is going to be an example where what's going to happen, kids. Okay, now, we've in the past talked about 2 equations, 2 unknowns having many solutions, but what I want to point out today is this. This is kind of a special case right here, so you might want to put a star by example 3. We're going to have many solutions, but I want to show you how do you describe that. Describing your solutions is very important. So describing your solutions today, instead of just saying many solutions, this is going to be very new for you today. Okay? So here we go. Let's pick out a variable, x, y, or z. Which one of the variables, x, y, or z, do you guys want to change to make work here? Or is there one that's already going to work? Which one? X, Y, or Z? Which one has the same coefficient in front of it? The Y's already have a same coefficient in here. So if I look at these right here, kids, I say, well, if you look at all these Y's right here, whoops. If I look at all the Y's right here, isn't the coefficient 2 on them already? And that's a really good thing, isn't it? Okay? So here we go on this, kids. Making sure here before we go on this example. Everybody have notes? Okay. So take a look right up here, guys. Let's work with this first one. I'll blow this up a little bit. Help me with this first one right here. If the Y's are what we're highlighting right here, what's going on? Okay, the Y's are what we're highlighting right there because they're all the same. Guys, take a look at the signs on the Y's for the equation 1, equation 2. Signs the same or different there, kiddos? They are the same. So am I going to add these first 2 rows or subtract? Subtract, you bet. Very good. Okay, so help me out here, kids. Let's do that. Where the hell are you guys on now?
Who said fuzzy?
I did.
Did you? I didn't even hear it.
I just heard,
Well, good, Jay. Give yourself a pat on the back, all right? Okay. I don't think anybody even had it out, did
I
they?
said the wrong thing, though.
Did he look at you? No? Don't worry about it. We're good. All right. Help me out, kids. 2x minus 10x. What would that be, kids? 2x. Oh, I should right over here. We're going to subtract, right? Subtract. Okay, 2x minus 10x right here, kids. What would that be? Negative 8x. Okay, the 2 y's will do what to each other? This is like negative 2y minus a negative 2y. What are they really going to do to each other? They're going to cancel, aren't they, then? How about 2z minus 10z? Negative 8z. And, gosh. How about 12 minus 60, kids? How much?
48.
Negative 48. All right. Good. All right, how about row 2, row 3? What do we have to do there? Have to add them, don't we? Because the two y's have opposite signs. Very good. So how about 10x plus 2x? 2 y's are gone. And what else? 72. All right. Okay. So now we're down to 2 equations with 2 unknowns, right? All right. Now I want to show you why this has many solutions, because this one's going to get tricky for us, and I want you to be very careful on this, okay? Help me out here, kids. In this right here, the 8 and the 12, 8 and the 12, can you guys think of, let's look at the x's right here. Can you think of the x's right here, how you would solve that right there? In other words, can you think of the least common multiple for 8 and 12? I agree 48 would work. There's actually a smaller one that we'll use in the notes here today. How much? 24. Yeah, let's go 24 with this, okay? What would I multiply the 8 by to turn this to a 24, kids? What would you multiply down here by? 2. Okay, let's check this out, all right? The top is going to become now the following. It's going to become negative 24x minus 24z equals, somebody run negative 48 times 3. I think it's negative 144. Is that right? Somebody take negative 48 times 3 for me.
144.
Negative, right? Okay, and I'm going to double everything down here. This will be 24x. 2 and 12z would be plus 24z. Forgot the x right there, didn't I? And 72 times 2 would be 144. Okay, first of all, let's show you what's going on here and how we get an answer, okay? You know, when we got to the one point in example 2 where we said 0 is equal to 39, we said that's not true. There's no answer. There's nothing we can do here, okay? What do you notice about the x's right here? Are the signs the same or different right here, kids? Signs the same or different here? They're different. So what are we going to do with these two equations now? Add them together. What's negative 24x plus 24x? Nothing. What's the negative 24z plus 24z? Ooh, nothing. How about on the right side? Negative 144 plus 144? Nothing. Okay, here's the deal. What we've done is we've exhausted ourselves. And we're kind of a unique case right here because the y's is what we chose first to cancel out. We're going to have to kind of go through some things here again quickly, but this is what's going on. Kids, right here, once I get down to this part right here, all the variables fell out. This time we have a value compared to another value. But in this equation right here, when I compare 0 equal to 0, tell me about the validity of that statement. Is that true or is that false? It's true. Okay? It is true. Okay, so if this is true, this is implying what, kids? Many what? Is this implying many solutions right here? Okay, this is kind of like, well, if you can think of 3 pieces of paper crossing, well, let me just show you what this is kind of implying. Okay, so right here, this is what this is really showing you right here, guys. X, Y, and Z values are going to form planes right here. Can you guys see this right up here? Where it says infinitely many solutions here? It's basically like three pieces of paper all intersecting right in the middle right here, and it forms a line. And that line's going to go on forever because these planes extend forever. That line's going to go on forever, indicating many solutions. Now, this is the part that gets tricky with this right here. Once you've had many solutions, our job now is to come back and do what? Well, over here we wrote down that when we get many solutions, we have to do what now? We have to describe what the solutions are going to look like. And here's how this is going to work for us, okay? All right, here's the deal. We got down to know that there's no solutions right here. We can't even figure out what y is equal to, or x is equal to, or z is equal to. But what we're going to end up doing is we're going to write these little linear triples, or this ordered triple, so that it represents what, if x was one number, what would y be, what would z be, okay? So here's what I'm going to choose to do, kids. I'm going to take a look here. We've always done this right here with row 1 and row 2 to try and get through this to begin with, okay? Now, when you get many solutions, here's a suggestion for you, okay? If you ever have many solutions, how about checking out what, I don't know. Check out row 1 and row 2. I'm going to say check x's or z's in this one, because what do we check first to start with, kids? What variable do we choose first? In other words, what variable do we say, hey, we're going to make these all the same right away? We chose the y's, and it turned out the y's were already the same to begin with, all right? Now, if you get down to this point right here and you say, hey, there's many solutions, I'm telling you, you have to come back and do what? Check x's or what? Okay, let's make all of the x's the same. Let's check the x's first. So let's come back here and make the x's the same. So help me with this, kids. If I'm going to make the x's the same, going back to this original equation, or system of equations, what would be the easiest x to turn everything into? 10, right? So you're going to multiply the first one and the third one by what? 5. Now again, we're only doing this if we get to the case where we have what, kids? Okay, and let me show you why we're doing this, okay? So let's go ahead and let's multiply everything, the first one and the third one, by what value again? 5. Okay, help me out up the top. All these 2's will turn into what? 10's, and this 12 will turn into a 60, won't it? Okay, so help me rewrite this new one. We're going to check the x's. So this is going to be 10x minus 10y plus 10z equals 60. This will be 10x minus 2y plus 10z. Why didn't I change this one up, guys? Exactly. And then everything down here multiplied by what? 5. So this will be 10x, 10y, 10z equals 60 again. What do you notice they all equal, kids, when I did that? Something like that happens. There's something really interesting going. Okay, let's look row 1 and row 2 again. Again, I only have to go through this again if we end up saying, ooh, there's many solutions. Okay, the 10x's are the same here, so am I adding or subtracting, kids? Am I adding or subtracting up here, kids? Okay, so let's do that. Row 1, row 2, subtract. So 10x minus 10x, what is that? It's gone, isn't it? Ooh, check this out. Negative 10y minus negative 2y. Wouldn't that be negative 8y? Because you're really adding 2y, aren't you? When you subtract a negative. How about the 10z minus 10z? It's gone. Okay. And then how about the 60 minus 60? something very interesting is happening right here. All right? Guys, it turned out for us that when we chose y right there to have that as a solution, we found out, right away that y was equal to what value here, kids? Okay, negative 8y is equal to what here? 0, right? Now, what I'm going to tell you is this right here. It turned out the x's and the z's fell out of both, but could I solve for y right here? What's y going to be, kids? Y is going to be 0. Okay, so from this right here, I can say, you know what? From this, I can say, y is equal to 0. Okay? Once you figure out a value right here, here's what you're going to choose to do. You ready for this? We know what y is equal to, right? Okay, here's the last thing that you're going to do. Once you know one of these values, go back into your equations that were up here. All right? We figured out what y is. So after you've done this, we were able to solve for y. So pick any equation to work with once you get a value. And I'll show you what many solutions looks like. Okay? We were able to find out that y was equal to 0. So what I'm telling you guys is this. Once you know y is equal to 0, go back and figure this out. Again, I know y being 0 is going to, this is saying y has to be 0 all the time, but there were still what in this, kids? Many solutions. All right, here's the describing part of this. Okay? Is it okay if I pick on the top equation, the very first one? Okay, I'm going to go to a new page. Actually, I can do this. Hang on a second. Make some room here. I'm going to go back to this original equation up here. I'm going to go to the very first one, the 2x minus the 2y plus 2z equals 12. Okay, this is the part that we know. We already know y has to be what, kids? Okay. So what can I plug in for y when I rewrite this new equation? Okay, watch what we get. This becomes 2x minus 2y plus 2z equals 12. Okay? But the y value is what? So what's really going to fall out of this? So I really have 2x plus 2z equal to 12, kids. Okay. Which variable have I solved for already? Which variable have I solved for already? We've solved for what? It means we need to solve for x. Okay. Here's the situation. Once you know one of the values up there, because you'll always have one of the values, what you do is you just get x alone from this equation and leave it in terms of z. And then what you're going to do is get z alone and solve for that in terms of x. So let's get x alone right here. What would I have to subtract out on both sides first, kids? To get this 2x alone, what would I do?
Subtract 2x.
So, yep. 2x is going to equal 12 minus what? You guys agree 2x would equal 12 minus 2z? You guys all agree with that? Now what are you going to do to get x alone? Divide everything by 2. So x will equal what minus what?
6 minus 3.
Exactly. X will equal 6 minus z. Okay? We have x alone. All right? Again, this mess only happens when there are many solutions. You're going to figure out one of the three values. One of them has to be something. Okay? Then, go back to what you had up here. Go back to this 2x plus 2z is equal to 12 again. Kids, check it out. Do we know what x is equal to now? Do we know what x is equal to? Do we know what y is equal to?
Yeah.
The only thing we would need to know then is what z is equal to, wouldn't we? Can I get Z alone here after this? Is it possible to get Z alone? Okay. Wouldn't 2Z equal 12 minus 2x there? Subtract 2x from both sides. Agree? Now you're going to divide everything by what? 2. Okay, so what's Z going to equal? Six minus x. Oh my lord. Okay. What ends up happening in many solutions like this is the following. Okay, you're going to find out that you get to this point right here. You're going to get a comparison. It says, hey, 0 is equal to 0. And you can say many solutions. And it would be great if we could just be done there. But they're not in three equation systems. All right. What you have to do is describe the values. Okay, you know the y value is going to be 0 based on the work that we did here. And then after you've got one of these values figured out, plug it into an original equation, get x alone, and get the other variable. In this case, we were able to solve for what, kids? Y. And then once I knew what y is, go plug it in to your original equation, then just get x alone and get z alone. Okay? Once I knew that y was equal to 0, isn't y always going to fall out? It is. Okay? So the way you're going to write your solution for this is the following. I'm going to put it over here in ordered triple form up here with a pen because I can't get it on screen. What's the x value equal, kids? What's the y value? What's the z value? Holy low. Okay. Many solutions are going to be described this way right here. Okay. This is how you're going to describe it. The first one's going to be 6 minus z. We know the y value is 0. And 6 minus x. Okay. That's pretty tough. That's pretty tough. All right. So we'll spend some time working on that and preparing for it. I'll make sure you guys at least have that down first. Everybody have that down? Good? Got it? Okay. Hey, guys, what do we say about this course? Going to be easy or going to be kind of challenging? That's pretty challenging, isn't it? Challenging? Not challenging? I'll show you challenging here in a little bit, all right? Okay, let's apply this stuff, kids. Here we go. Let's apply this. Last example, and then I'll get you going on a quick quiz here. Example 4, solving real-life problems. How about volunteer to read that for me?
Colin has $1.27 in quarters, nickels, and pennies. He has twice as many quarters as pennies. He has 11 coins total. How many of each coin does he have?
Okay, so he has some quarters, right? I'm going to let X represent the number of quarters. Is that okay, kids? What else does he have?
X amount of nickels.
He's got a certain number of nickels. Now, I let X represent the number of quarters, so it would probably be a good idea to let Y represent the number of nickels. Gosh, what else does he have besides quarters and nickels? Pennies? If X is quarters and Y is the number of nickels, we probably better let Z equal the number of what? Oh my gosh, there's that XYZ thing again, isn't it? Okay. So here's the deal. How many total coins does he have? 11. Okay. Let's just read through. He has 11 coins. So the number of quarters, X, plus the number of nickels, Y, plus the number of pennies, Z, had better equal what value, kids? How many?
11.
Okay, we have 11 coins total. So the number of quarters, X, plus the number of nickels, Y, plus the number of pennies, Z, had better add up to 11. And there's one equation for our system. Okay? Next thing says he has twice as many quarters as pennies. So if he had 2 pennies, how many quarters did he have? had 2 pennies, how many quarters does he have? 4. Okay? So what we're saying right here, guys, is this. He has twice as many quarters. So the number of quarters is 2 times the number of what? Pennies. The number of quarters, which variable? X is equal to 2 times as many what? Pennies. So X is equal to what? You guys okay with that? How much money does he have? Okay, how much is each quarter worth? Okay, so here's the deal. Last thing I'm going to write up here is 25 cents, 0.25x. 25 cents times the number of quarters. Plus, how much is each nickel worth? 0.05 times what? And he has some pennies. What's each penny worth? How much money total? Okay. How many equations did I write?
3.
How many unknowns are there up there? Okay. This would be your system right here if we had to start this. Now I don't like this second one right here because when we work with this right here, kids, you want to have all the variables on the left and your constant on the right. So I want to move this 2z in this second equation over here. So how am I going to get 2z to the left of the equal sign? It's a positive 2z, so I can get that to the left of the equal sign. Yeah, so I'm going to rewrite this second one. I don't like the way that this second one is written. So we're going to change that to x minus 2z. And now watch what I do. How many y's were in that second equation, kids? There wasn't anything. I'm going to write that plus 0.0 or plus 0y minus 2z. Now that I've got that 2z over to the left, 2z was on the right, and that was the only thing over there. What would really be over here on the right now, kids? 0. Okay, are you with me on that first? Are you with me on that? Okay, so that's what you need to write that second equation as then, kids. Okay, I'm going to just tell you, let's pick on the x's. How many x's do you have right here? How many do you have right there? 1x. How many here? 1. How many here? So what would you have to multiply the 0.25 by to turn that into 1x? In other words, how many quarters would make $1? Okay, so I'm going to multiply everything down here by, let's do that, 4. Okay, so let's rewrite the system. Top one, is that changing? Top one changing? I'm multiplying anything by it up here? So I'm not changing the first two, right? Question wants to know how many quarters and how many of each coin does he have? So we got to solve for x, y, and z. Okay. What's the new one going to become down on the bottom if I multiply everything by 4? What's 0.25 times 4, kids?
X.
1x. What's the 0.05 times 4 going to get me? It's like 5 cents times 4. So 20 cents, 0.20y, or just 0.2y. And then 0.01 times 4, kids. 0.04z. Thank you, Sterling. Oh, let's see, $1.27 times 4. Is it okay if I just tell you what that is? How about 508? All right. What have we established, kids? Which variables are the same now? The x's are the same, so let's take a look in the first two. If the x's have the same sign, am I adding or subtracting? Yeah, subtracting. All right. The x's are the same in the second two and 3, equation 2 and 3. So again, between these two, won't you subtract again? Okay, so between these two, you'll subtract. Okay, so I'm going to move my work over to here. All right, let's get down to two equations. What's x minus x going to be, kids? Nothing. What's 1y minus 0y going to be, kids? I'm sorry? 1y, right? So we're going to have 1y. What's the 1z minus negative 2z? Careful. When you subtract a negative, this is like adding, isn't it? So won't this be plus 3z? Equals, all right, 11 minus 0. What's 11 minus 0, kids? Okay, so we've got that one. So let's work, I should put a strike through here so we know that's a z. Let's work through this next one. Same thing right here. X minus x. 0y minus 0.2y. Negative 2z minus 0.04z. And then 0 minus 5.08, kids. Zero. Yep. Okay, we're getting close on this. We're down to two equations, two unknowns. I'm going to work with the y's in this one. Is that okay, kids? This is like 20 cents y. So how many 20-cent increments would you need to get up to $1 y or one whole y? If this is like 0.20 here, kids, how many of these would you need to get up to 1y? Oh, come on. 5 of them. So multiply the bottom one by 5, right? Okay, so here's this. Y plus 3z still equal to 11. And then 5 times negative 0.2y is negative 1y. 5 times negative 2.04 is negative 10.2z. And 5 times negative 5.08 is negative 25.4. What variables have I gotten to be kind of the same there now? The y's. Signs the same or different there? So you're going to add or subtract? I'm going to add them. Okay, let's add them. The y's are going to do what when you're done here, kids? They're gone. Okay, what's 3z plus negative 10.2z? Positive or negative, Jaden? Negative 7.2z. We have to add, right? There's more negative than positive. Help me out. 11 plus negative 25.4. Ooh. That is negative 14.4. Oh my gosh, what can we solve for, kids? Z, can't we? What's z equal to when you solve that? Z is equal to 2. Okay, so z represented the number of what, kids? What does z represent? How many pennies do we have? 2 of them. Okay, let's go back up here. Let's take 2 and plug it in right here. So what's 3 times 2, kids? We're plugging 2 in for z. What's 3 times 2 here? 6. So y plus 6 equals 11. Y plus 6 equals 11. What's that make the y value? 5. Ooh, 5. How many nickels do you have? 5. Let's go back to this first one right up here now. I know y and z. What's y's value, kids?
5.
What's z's value? So if I put 5 and 2 in here, isn't this x plus 7? If I put it in right here, isn't that x plus 7 equals 11? So what's that make the X value?
4.
How many quarters do you have?
4.
Do I have twice as many quarters as pennies, kids? Do I have 11 total coins? 4 plus 5 plus 2? Do I have, how much money do I have here in 4 quarters? How much money do I have in 5 nickels?
25 cents.
And how much do I have in 2 pennies? What's that all add up to? Are we right? Okay. 4 quarters, 5 nickels, 2 pennies. Awesome. Okay, again, guys, there's going to be a little struggle.